One. Hello, everybody. We're back. It's only been 8 minutes since we did the last one, but we're back again. I'm Tony Darnell. I work at Space Telescope Science Institute, and this is Carol Christian. We're back doing a meeting recap of the 225th meeting of the Double AS. We're at our booth, and we are doing a lot of things here at this meeting. And one of the things we're doing, it's really interesting. I have two members of the staff at the Institute with me. I have Tony Rogers and Lee Quick. They're both working on something that I want to make you guys aware of, because I know you want to get Hubble data. And right now, to do it, you use the Mikulski Archive
for space telescopes.
And that's right.
MAST.
Right, we call it MAST, and you get there at mast.stsci.edu, right?
Yep.
And you type in things and you get data out. But what Tony and Lee are here demonstrating at the meeting at the booth here this week is a new interface that makes it easier for you to get Hubble data. And so he's going to give us a quick demonstration of it, and then we're going to follow up in February, I believe, with when this gets released, with a longer hangout that really goes in depth and shows you how to use it and get specific data sets out of the archive. And it's not just Hubble, is it? It's also...
That's correct. It's got Hubble, Galax, IUE, Fuse, Kepler, many others. Yeah. So it's a one-stop shop for all the visible and UV data that's in our holdings.
That's right. And we've got other missions coming online as well in the future, and as they are added, they will also be accessible through this interface. So I'm gonna go back and drive the camera, because I want to zoom in on it while Tony and Lee tell us about what they got.
So I was going to comment that one of the reasons that we have these demonstrations is because we have a lot of the science community here, and the idea is to introduce these interfaces and the tools that Hubble offers to the community, get their feedback, make sure that they are aware that these tools exist, and then if they have specific questions, we have people like Tony and Lee right here to answer them. And that helps us improve the system, and also it's a great way for us to let them get hands-on with the tools. So at this point, we're going to have Tony and Lee talk about this new tool and how an astronomer, a dumb astronomer like me, could use it to get some data out of the archive.
Okay, are you going to hold the mic?
I will hold the mic, and then you can drive.
All right, so I've loaded the MAST website right here on our browser.
I'll stand over. You go over on that side.
I go to that side?
You
Okay.
you stay here. Lee can go on that side.
Okay.
It's easier for me to hold the
All right.
microphone.
And the URL is mast.stsci.edu, but you can also get it from the archive classic page just by entering your favorite target right here, right in the main archive.stsci.edu, and then that will launch you over to the MAST portal page. So what I'm going to do, let me spin sideways here so I can find my cursor, and it'll launch you to this interface right here. This is a new interface. Once again, it's a one-stop shop for all the holdings within the archive. So I'm going to just do a simple search, what we call a positional search. It's kind of your bread and butter way to find your data in the archive. The interface is very interactive. It's really an application. It's not necessarily a web page. So you don't want to hit the back button. You'll lose all context here. This is a single page app. You just stay here and work within your data. So I just searched M60 right here, and you can see I got quite a few observations that came out of the archive. And if I can lift my glasses.
371.
There we go. How many?
371.
371 observations, and they're across many missions. So if you can see right down here, you've got HST, Hubble. Can you read those off for me, Lee?
Swift, Galax, IUE, and HUT.
Okay. So what I'm going to do is I'm just going to downsample to Hubble right here, and because Hubble is sort of the flagship mission.
So what you may have seen is that, so we haven't explained to you, and they're about to, is that these are where the observations are, and M60 is behind here. So if you Google M60, you'll see what an image of that galaxy looks like. And when he's just selected HST, that's all that's left. The other things that were on there were the other observatories that had observed it.
Well said. So yeah, we filtered down all of the records, and we're just looking at the Hubble records right now in the grid. And over in the sky view, same thing. Just we call these footprints. They're the outline of each aperture on the sky. And this way you just can have a context. You can keep in context of the data you're interested in. So I'm going to downsample a little bit more. For example, if I wanted
So wait.
Yes?
So, okay, boys and girls, does anybody know what that shape is? That's a wide field planetary camera 2. That's the old instrument. So some of these are the older observations. So you know that from the classic wedge shape. And so you can tell right away that WIFPIC 2 has taken observations, and there are many, many more observations if we scroll down.
correct. So do you want to filter on WIFPIC 2?
No.
Carol? No.
I want new stuff.
New stuff. Okay.
WIFC3IR.
Okay.
WIFC3IR.
All right, hang on.
Brand new instrument since 2009.
Okay.
All right.
Now you're looking at just the WIFC3 IR observations taken around M60, and you can see it downsampled. I should mention over here on the right, the red dashed circle represents our search radius, and in the center, there's also a crosshair representing the actual center point of our search. And this was resolved up here when I entered M60. The magic happens where names are resolved to positions, and all the software takes care of that for you. You just have to remember the name of your favorite target. So at this point, let's say I just want these observations around the center of the galaxy, and I don't really want that one on the edge. If you've noticed, I'm getting a little hover action when the mouse goes over that. It gets slightly brighter. That means it's selectable. So I went ahead and selected those, and the footprint is now brighter in color, indicating selection. And over here in the grid, they were also selected. They went blue, and the far left checkbox is indicating that they're selected. So if you were just going straight through and you wanted to get out and get back on with your life as quickly as possible, you would just come up here and just add all of those selected records to what we call the download basket. And right now, how many do we have there, Lee? How many?
33 files.
Really good, Lee. You're doing really well. Because we can't read it back here. So we have no idea. You can tell us 1,000 files.
Yeah.
We don't know.
When you do that, can you just do one Price is Right?
Yeah, thank you.
Thank you,
Vanna.
Janice.
Lee Vanna.
All right, Janice from the Price is Right.
Yeah, right.
Okay, so I'm going to select all of these files. These are actual files at this point.
Greedy, aren't you?
Yes. And you can now save them directly to your hard drive. And the download basket lets you decide, do you want them bundled in one giant tar gzip, or do you want to save it as a wget or curl script? I'm just going to keep the default, and it's now bundling up that tar, and then when it completes, you'll see it, Chrome will automatically download it to my downloads directory. So, something's happening. This is good. We're at 39% complete. So, while this is happening, I can tell you.
So a question.
Yes.
So just to make sure people understand, this data is not here. It's reaching back to Space Telescope and getting the data, finding it, and then pulling it right here so you could work on it if you want. Is that right?
Yes, and if you look down here in the very bottom corner, if you can, Tony Darnell can zoom in, that's basically, here's my tar GZ, nicely, and it's ready to be opened up on your local hard drive, and it's got FITS files, it's got catalog files, it's got everything that MAST essentially knows about the very center of that observation. So, so this is what I call, are we still live?
Yeah.
Okay. Well, I want a hug then.
Okay, all right. You did a great job.
This is the bread and butter pass through the app. You basically positional search, down select what you're interested in, add it to the cart, save it to the disk. There are many, many other features that are continuing to grow, and in February we'll demonstrate those. And the real goal is to push this entire application more to behave more like a desktop application. And you'll see in February the types of things we're talking about, where we'll be doing sort of pre-analysis. We can create color magnitude diagrams. You can load up spectral plots directly in the tool. You can overlay these high resolution images into the sky and overplot catalogs. So it's just onward and upward.
So I know a lot of you use the archive now, and you've made some beautiful images with it. Some of you are doing amateur astronomy with it. Some of you are making artwork with it. And I know there's several people that visit our Hangouts regularly who are even big fans of Zolt, who do the image processing. And so if you've used the archive before, this promises to be a heck of a lot easier, right?
Yes, that's correct. And that's the feedback we get from a place like this. When we show it to people, they stop what they're doing and they go, wow. And then they go tell their colleagues and they say, okay, this is what you got to see this. So that's good feedback from us. We usually just hear negative feedback back in the shop, but it's good to hear the user community actually appreciate the effort. And I think, and it's not just us, other facilities also are using, the web's changing, and that's what makes all this possible, essentially.
Yeah, we talk a lot about telescopes getting bigger, being able to see things we can't see now, higher resolutions, further back in the universe, things like that. This is the other side of the problem. You need to not only be able to take this data, but you've got to be able to ask good science questions of the data once you have it. And that problem is going to get worse and more, well, not worse, just bigger, and these kinds of solutions are going to be more important. So it's good that we've got an easier interface into our archive, because you'll want to be able to get the stuff as easy as you can, because there's so much to choose from. So you want to say something?
Yeah. Yes, that's why I'm taking the microphone. So in addition to the observer who might have said, oh, I want to look at this, and one time, which we've talked about several times before, of how do you get telescope time, then they want to get their own data as well as data from other telescopes and use that for analysis. But then, after they've done some of their own analysis, probably published a paper, anybody in the community can get the data and do new studies. And in fact, not most, but more than half of the published papers come from the archive, not from the original observer. And that's because these observations can be used for many, many, many problems to look at different things about astrophysics. So the original observer wanted to do a certain thing, and other people want to do other things, and combine data in different ways. So that's why the archive is so powerful, is that we're getting a lot more science by having this archive than rather than just shipping one data set to one observer.
Not to mention, just mention the time factor, the fact that Hubble has gone back and observed a lot of these targets now over 20 years. You can really start to see things like
like M16 this week, right?
Like variability and things like this are real
Higher
interesting.
resolution.
Yeah. So you can sort of see that, and we'll show that in February. You can actually see that directly out of the archive and find some very interesting, very variable sources.
That's right. There was a time when this new, relatively new term of transient astronomy is now going on, where you could see transients, events happening, and make animations of things like supernovas and stuff. So it's really an amazing time. So we will probably have a more, we will have a more detailed hangout when this gets released. So look for that. Carol and I will let everybody know when that happens, sometime probably in February. Good work. This is exciting. I can't wait till this comes live. So it's really cool. Okay. And all right. So now what Carol and I are going to do is go over to this table and finish up what we were going to talk about. Because, see how easy that was? Okay. All right. Yeah, we don't need that. Okay, so that is the archive update, and that's something that I've been dying to get you guys access to. So hopefully you'll be getting that soon. The meeting today has been really interesting. I went to a plenary talk. One of the funniest moments was I went to a plenary talk today where where an astronomer was trying to tell a whole room full of astronomers about parallel universes, and it was really.
I was very curious about that talk. I didn't get to go see it, so tell us about it.
It was the thing. Well, I didn't understand it was the thing, and I got a sense that he was struggling a little bit himself. Parallel universes, string theory. All of this stuff is basically, you have a theory that is, one of the points in the talk was, if X implies Y, then Y must be true. And so if theories that we know are true, like quantum mechanics, things like that, imply something like string theory, then string theory must be true. And that, of course, that's a line of thinking that you can argue with all you want, but it was the starting point of it, and he was talking about what would parallel universes look like and how would we ever know and how many would there be. I did not understand a word he said because that stuff always, string theory makes my head hurt every time someone tries to explain it to me. I just don't understand it. It makes me mad. But anyway, that was the talk I saw today. The amusing part of it was his his screen went wonky, and so you can only see just a part of it, and he was quite amusing.
Oh, no.
And he was quite entertaining with being able to talk about, to make people laugh about it and stuff. It was an entertaining talk. What about you?
Well, we've talked a little bit in a previous hangout about a lot of the things that I went to see. Of course, we had a lot of sessions, as we do. We have these individual sessions where people give 10-minute talks on different topics. There's a lot. There were a few talks on exoplanets and debris disks, but the topics seem to move more towards the nearby universe and then distant universes. A lot of data on how galaxies are formed, how they interact, how you measure them, multi-wavelengths, not just Hubble, but many observatories, the data put together, and what we can learn. And one of the questions is, when you look back in time, when did star formation start in galaxies? And so there were a lot of those topics today.
Did you go to that one on gravitational waves?
I did not get to go on gravitational waves.
Because they still haven't found any, right?
They still haven't found any. So the idea with the gravitational waves is you're looking for some phenomenon where there's a dramatic change in the gravity, and this can be a collapse or something, some catastrophic event where the gravity changes a lot, and that would be, if it could be detected, that would be an evidence that gravity works with waves. And it's a very difficult experimental problem, and all kinds of sophisticated instrumentation have been built and new techniques, but as of yet, there isn't really any definitive evidence of it. That doesn't mean it doesn't exist. It's just very, very hard to observe. And I think that kind of addresses your previous comment about multiverses, is that it's fun to speculate about them, but I think probably the bottom line, at least for an astronomer like me, is what's the evidence? And if we believe something exists, then we have to find a way of getting data on it. Sometimes your experimental technique does not work out that you can detect it. That doesn't eliminate the theory, it just means you don't have the right instrumentation yet. But it does draw one closer to the idea that maybe this thing that's being proposed doesn't exist, or it's not being proposed in the correct way. So that's kind of how we think. Yeah. Show me the data. And a lot of my friends will tell you they're really tired of me saying that all the time, but they'll say, well, what about this and what about this? And I will say, tell me where the data is and what's the evidence for it. And that's how astronomers think. So I can understand how people would have had trouble with this talk, especially if the view graph didn't work.
Yeah, and really, because string theory. Well, the thing about string theory that bothers me the most is you're right. It's one of those things where the theory seems sound, but there's absolutely no way. You're talking about strings on order of the Planck length. You can't. It doesn't matter how good we get at building instruments. It's an impossible length to measure. It's simply bounded by the universe we live in.
Yeah.
So what's the point? I don't. That's my biggest problem with string theory.
And so for people who weren't with us before, something else that happened, which everybody always waits for, is the NASA Town Hall.
Yep.
And the NASA Town Hall is when NASA Astrophysics, which is part of the Science Mission Directorate. So Science Mission Directorate in NASA, there's the Administrator, Science Mission Directorate, and then there's Astrophysics, Earth Science, Planetary, and Heliophysics. The people who come and address the American Astronomical Society is the head of astrophysics. And so he gave his view of how we can prepare in the next 5 years for the decadal report and what he is looking for. And so it's this tension between this community saying, what we'd really like to study is this, but we have to face the reality of the budget and understand that Congress and the American people, through taxpayer dollars, are only going to support a certain amount, reminding everybody that the NASA budget is a fraction on the dollar, not even a penny on the dollar, and the science budget of that is even smaller. So it's nothing like DOD or welfare or anything like that. It's a tiny, tiny amount of our gross national product for the United States, but still we have to spend it carefully. And so we can wax eloquent about all the things we want to study, but then you have to come back to the reality. What kind of money do we have, and can we need to responsibly spend it? And so the head of astrophysics gave us his view about the things he sees emerging in the community, the big ticket items, not prescribing our science, but just saying, this is what it looks like to me. So if that's what it is, tell me what kind of missions you need and all the technology you need. And if that's not what it is and you need to add another box, tell me what that box is and what kind of technology do you need there. So that's kind of how we do this. And every year we get an update with him, have a discussion, and try to do more studies and make preparation for the decade report, which will happen around 2019, 2020.
Right, and another thing he did, was it gave us a status report on some of the missions and how they're doing now and how they're being funded. And one of the things I was very gratified to see was, WFIRST was the top priority of the last decadal survey, and that the funding is starting on that now, and it looks like progress is being made. In 2015, what they're going to be building is starting the, I forgot what it's called, the technology development phase what Mark Postman was saying this morning is a lot of stuff still needs to be developed and built and even invented, much like with James Webb. So that, I guess, has finally started this year, right?
Do a study of what technology you think maybe doesn't exist but might be possible, and then so you do the study and then you say, okay, this is a technology we think that in 5 to 10 years we can actually develop. It's kind of like making new cars, where you say, okay, in 5 years we think the car will be autonomous and we think we can do that, or no, we can't. So matching the science, studying what's needed, studying the technology, and then saying whether it's realistic or not, and then can we afford it? So it's a long process.
Yeah, so it's always a well-attended event, and tomorrow there's going to be one on the Hubble Space Telescope.
Hubble Space Telescope will have a town hall around lunchtime, and we'll talk about Hubble, a little bit about what we talked about today as well. What is Hubble going to be like in the next 5 to 10 years? What's its role in our community? And then we're going to have some updates on the frontier fields and a couple other topics.
Yeah, Ken and Jen and various other people are going to be talking at that one. So,
and then the anniversary celebration, that's right. We're going to have some talking about that, and we'll have a guest from NASA headquarters tomorrow who will talk about 25th anniversary celebrations on our Hangout.
Okay, so that's pretty. Anything else that we can think of about today? We did our Hangouts earlier today. A lot of good stuff coming out of the meeting. We're trying to cover as much of it as we can, but there's just too much. We get the stuff that we find the most interesting, and so that's. I guess we'll stop for this one. Anything else you want to add, Carol?
Nope.
Okay. All right. So tomorrow we've got 4 Hangouts coming up. 10:30 over at the Northrop Grumman booth. We'll have Meg Urey, the president of the American Astronomical Society, talking about industry and astronomy and how they can interact. That'll be over at Northrop Grumman. At 1 o'clock, also at Northrop. Well, it might be here or the Northrop Grumman booth. I can't remember. Alberto and a colleague of his. We're going to be talking about exoplanets. At 3:30, we have our hangout on the Hubble 25th celebration kickoff, which is basically, we're kind of considering this week sort of the kickoff, right? And then we'll do a follow-up, and then that will be it from this meeting, and we will be done.
Until our regular Hangouts next week.
Yeah, are you holding up? Are you getting tired? I'm getting tired.
These are very long days. This is one of the most intense meetings that I've been to, because very often they start at 8:30 in the morning, they go to around 6, and then the exhibit hall closes. But this meeting, we've had many meetings all the way up until 9 o'clock.
I know.
It's like 12 hours every day.
Yes, and I've actually. Yeah, and I've actually recorded some of them. There was the UVORI session that was on Monday. I recorded it. I also recorded the JWST Town Hall last night, and I'll record the HST Town Hall tomorrow. They won't let me live stream those here, but I am recording them, and they will be posted to our Hubble Site channel, YouTube channel. So if you haven't subscribed to Hubble Site yet, you need to. This is how you find. That's the best way to find out about the Hangouts that we've got coming. Also follow us on Twitter, Hubble Telescope, as well as G+. We're also Hubble Space Telescope. So, all right.
That's it.
That's it. Thank you all for watching. We'll see you guys.
All the visible and UV data that's in our holdings.
That's right. And we've got other missions coming online as well in the future, and as they are added, they will also be accessible through this interface. So I'm gonna go back and drive the camera because I want to zoom in on it while Tony and Lee tell us about what they got.
So I was going to comment that one of the reasons that we have these demonstrations is because we have a lot of the science community here, and the idea is to introduce these interfaces and the tools that Hubble offers to the community, get their feedback, make sure that they are aware that these tools exist, and then if they have specific questions, we have people like Tony and Lee right here to answer them.
mass.stsci.edu, right?
Yep.
And you type in things and you get data out. But what Tony and Lee are here demonstrating at the meeting at the booth here this week is a new interface that makes it easier for you to get Hubble data. And so he's going to give us a quick demonstration of it, and then we're going to follow up in February, I believe, with when this gets released, with a longer hangout that really goes in depth and shows you how to use it and get specific data sets out of the archive. And it's not just Hubble, is it? It's also...
That's correct. It's got Hubble, Galax, IUE, Fuse, Kepler, many others.
Yeah.
So it's a one-stop shop for all. Classic page just by entering your favorite target right here, right in the main archive at stsci.edu, and then that will launch you over to the MAST portal page. So what I'm going to do, let me spin sideways here so I can find my cursor, and it'll launch you to this interface right here. This is a new interface. Once again, it's a one-stop shop for all the holdings within the archive. So I'm going to just do a simple search, what we call a positional search. It's kind of your bread and butter way to find your data in the archive. The interface is very interactive. It's really an application. It's not necessarily...
Hello, everybody. We're back. It's only been 8 minutes since we did the last one, but we're back again. I'm Tony Darnell. I work at Space Telescope Science Institute, and this is Carol Christian. We're back doing a meeting recap of the 225th meeting of the Double AS. We're at our booth, and we are doing a lot of things here at this meeting. And one of the things we're doing, it's really interesting. I have two members of the staff at the Institute with me. I have Tony Rogers and Lee Quick. They're both working on something that I want to make you guys aware of, because I know you want to get Hubble data. And right now, to do it, you use the Mikulski Archive
for space telescopes.
And that's right.
MAST.
Right, we call it MAST, and you get there with...
And that helps us improve the system, and also it's a great way for us to let them get hands-on with the tools. So at this point, we're going to have Tony and Lee talk about this new tool and how an astronomer, a dumb astronomer like me, could use it to get some data out of the archive.
Okay, are you going to hold the mic?
I will hold the mic, and then you can drive.
All right, so I've loaded the MAST website right here on our browser.
I'll stand over. You go over on that side.
I go to that side?
You
Okay.
You stay here. Lee can go on that side.
Okay.
It's easier for me to hold the
All right.
microphone.
And the URL is mast.stsci.edu, but you can also get it from the archive.